Welcome everybody, welcome to HVAC Startup Technicians. Hey guys, how's everybody doing? Welcome to HVAC Startup Technicians. And today we're going to talk about CFMs and BTUs, and we're going to talk about how we know when our system is working correctly. So we're going to dive a little into those things, and I'm going to just show you some numbers first, and we're going to kind of discuss those numbers as we go forward. All right, guys. So let me just show you some numbers. So here we go. So you guys can see we're talking about CFMs and we're talking about designs, and these are one of the important numbers that you should know. And I have on my screen a 80% furnace. We need 130 CFM for every 10,000 BTU. So there is a really easy way to work that math out. If you're working on an 80%, let me say it's an 80%, 80,000 BTU furnace, we're gonna do 130 times 8, and that will give you approximately 1040. But that is not where you end. You also want to look at your ductwork. You also want to make sure that your ductwork you use is gonna be appropriate for the furnace. If you look on Amazon or any of those sites, you could get one of those duct slider rule, and it will actually also tell you how much CFM it is rated for. So we're going to dive deeper into 80%. We're going to talk about 80% furnace. 80% furnace, it is one of the furnace that I love because compared to a 90%, it's not condensing, so it's not producing water. So, and a good way to kind of know what 80% furnace is, you're going to see that flue. They're going to have that metal flue coming up. So that's a good way you could identify if you look in your basement or you look in your house, if you have a 80% furnace or if you have a 90% furnace. The 90% furnaces, what they're gonna have those flues going out. So they go have like an intake and an exhaust. But on the 80%, they normally have that chimney and they have that metal cap where they kind of, let all the exhaust through that. So that's a good way you can tell if you look in your basement and you see you have one metal flue going up, or if you see you have two plastic flue going outside. That is where you can tell whether you have a 80% or 90%. So I want to thank everybody for that is tuning in. So we're gonna go a little bit deeper, and if you look at the slide, I have a slide up there. It also talk about, I went ahead and I did different numbers. So I said if I had a 80%, 80,000, I was getting 1040. But what about if we was doing a 60,000 BTU furnace? How would you work out how much you need, how much CFM you need? Well, you're gonna take that same 130. We're sticking with 80%. We're not going to 90%. I will touch on 90% in a little bit. We're going to take that 130 times 6. So you see how easy it is to work? And if you do 130 times 6, I think they're going to give you what? 780 CFM. And for the people, CFM just means cubic feet per minute. So that's all it is. It's all we're talking about is the air going up that you're going to feel in your registers. So that is exactly what we're talking about, how much air you have going. If you go through the vent and you feel like you're hot or you're cold and you say, hey, man, I'm not feeling any air coming out, we're really talking about how many air we have coming out of the vent. As we go a little bit deeper, I'm still sticking with 80%. Our fan speed is very important. So how to tell if your system is working correctly, if you have the right airflow. Think about like you have a fan, and the speed of the fan that you put will determine how much air, how fast that fan is running. So what you want to do, you're going to look at your manual. I think most of those furnace, unless the guy didn't leave the manual with you, but they're going to have a manual. And in that manual, you will see the CFMs and where you need to have your fan. And I did another video on my channel about fan speed, which is just 3 wires coming out from the furnace. So you're gonna have a park, you go have a high, you go have a medium or medium low or medium high. So you go see those numbers, and then you're going to look at the book and you're going to kind of correspond those numbers. And all you have to do is kind of pull them out. I mean, they're pretty easy to pull out. You could just use your hand, pull these numbers out, one out, and then you could put it in pack, and then you could push it back in, and you could say, okay, well, if I want medium, that's going to give me close to 1040. Sometimes it might not be exactly 1040. You might see you getting 1060, 1050, but you get a picture that you continue staying in the ballpark for what you need. So this is really, really important stuff. Um, and again, doesn't matter I will repeat this, doesn't matter the BTUs or anything. We're just working on the CFM part of it. Once we're talking about BTUs, we're actually going in gas pressure, which I hope to get to a little bit. So I'm gonna continue now, and I'm gonna just kind of touch the base and kind of talk about 90% furnaces, because 90% furnaces, the numbers are a little bit different. So remember I said in the 80% furnaces, I said that that we're doing 130, but now we're doing 90%, we're doing 150 per every 10,000 BTUs. So 150 times every 10,000 BTUs. The math is simple. The math is the same. So you're going to do that 150. Now you're doing 150 times 8 if it's a 80,000 BTUs. You're doing 150 times 6 if it's a 60,000 BTUs. And if it's a 70, so you guys kind of get the picture. So that's what you're doing, and you're checking to see, again, I said, ductwork, fan speed, if it is doing what it's supposed to do. That is like step number one. I wish you guys would kind of go downstairs and check on your furnace. Even though you don't have the manual, if you just pop the covers off, because most of those furnaces have a cover that is a safety. So once you pass the cover off, the furnace will kind of shut off, and you could just look at the bottom of that furnace. So I guess most furnaces will have that two-part, where one is by your inducer motor, which is one of the first thing if you get into your sequence of operation. That's the first thing they're going to start. But the bottom part of it, it is where you will see your board, and you will see those wires that you could take out, and you can change your fan speed. And I guarantee if you change your fan speed and you can look and see what it's, you may feel a difference in the winter if you're cold, because you may have that fan speed too high. And a myth out there is that people think that if the fan speed is really fast and they have it on high, that you're going to get a lot more heat. No, you're going to get a lot more air, and the heat will be diluted. So it's very important to check those things. This is very, very important. If you check that, you may feel a difference. Might not feel it immediately. It may take about 6 to 12 hours before you can feel the difference. And while I'm talking about this, I just want to address a myth that is out there that I've heard it, and you guys could tell me if you heard that before, that if you have one room and you're not getting air in that one room, that you could just shut a vent off and it would push air to the other room. That never happened. What you could do is, if you had dampers in your ductwork, like if you look through your basement and you see that you have some dampers, you can kind of shut the one off. There's just dampers like little leads downstairs in your basement where you can kind of shut them off. That could kind of, help your airflow. But just shutting off from the registers upstairs in your room, I mean, the air is really dumb. It doesn't know, hey, how could air can't really turn back and go the other way? So you're just creating what you call a high static pressure into the duct. So you're not really doing anything, so it's very, very important to make sure that you're doing the right thing and you have the system for what it was determined to do. Having too much air coming through there is bad. Having not enough air is bad. So we're gonna dive deeper into this. So I just wanted to touch a little base and talk about, guys, as I said, CFM designs. And this is one of the most important things. So I'm gonna leave the screen up for a while. I'm gonna explain it a little bit, and maybe sooner or later I'm gonna just dive a little deeper, you know, into the cooling side of it. But I'm gonna leave this up because these numbers are very, very important. This is what you could use to determine. And you may ask, if how do you know how much BTs you have? You just have to kind of read your nameplate or look in the back of it, and it will tell you BTUs. It will tell you voltage just from looking at the back of your furnace. You could kind of get, a lot of stuff. So if you guys, anybody that want to write down this information, you want to test it and see if it works for you. Don't be scared to pull it off. You're just talking about you don't have any high voltage there, but and once you pull the furnace off, it would also disconnect power, so you don't have to worry about electrocuted and a furnace. You only have what, 24 volts, so you really can't do anything to you. So you find to just try these things and let me know how that work. If those things work for you, it will be really, really, really good to know, if that things work for you and how you do. So tell me about this, guys, and I'm gonna just show you some more stuff, and you're gonna tell me if this could work for you, if it's something that you're willing to try, and how is it working for you guys. All right, guys. So let me just show you this here. So let's come back here now, guys. So this is what you will see most time. You see furnaces. I'm showing you some diagrams of some furnaces and showing you how the airflow goes and BTUs. And I know we talk about BTUs a lot, and guys may want to know BTUs. It just means British Thermal Unit. I think it's something from the British, and it's just a simple explanation they gave for BTUs, which is the amount that it takes to raise 1 pound of water, one temperature above. I mean, it's a really, really simple explanation, but in my view, dumb explanation. So I always say the good way for me to do BTUs and for me to grasp the BTUs, I look at it as a match. Like when you buy a match and you see all those matches, when you light it, hey, that's one BTUs, and that's how to tell. So if you have 80,000 matches there, that's a 80,000 BTU, and you kind of get the picture. So these are what most of your furnaces would look like. So I just have some diagrams showing you that. And I'm still sticking with furnaces. Still sticking with 80%, 90%. Where I think we cover that. I don't want anybody to get confused. I just want to talk about the design, and I want to take the opportunity also to talk about cooling. Because once we're talking, if we design is for heating, we also have to have the appropriate design for cooling, to make sure, man, that you're not cold. You're cold. You're getting good air. You know, most furnaces, no, sorry, but most air conditioned unit is only designed to work around about 85%, humidity. So when the side is really hot, I guess some of you guys might find that you have the AC on, but damn, man, I'm still hot. And sometimes when night fall and the temperature kind of come down, you will find that most of the time you kind of come down because your humidity kind of drops, so you kind of feel better. A good way, one of the easiest way, and that I think you could work with that, and you could try it if you have a AC outside and in the summertime and you're really hot and nothing happening. Go there and just take your hose and wet that coil down, because remember that coil is actually pulling the hot air and it brings it inside. So if you had a coil wet outside, you just spray it on your air conditioning unit. I guarantee you're gonna see a big difference, and you're gonna say, "Wow, this thing kind of keeping my stuff cool." So It's good, it's good stuff, good stuff to know. um I just want to address another myth, is that when you're doing AC, that your fan speed should be a lot higher. No, it should not. It's not that. We're looking at, I will have to talk about BTUs again, because you could also work what your BTUs is outside. So every 12,000 BTUs, you need 400 CFM. So every ton, you need 400 CFM per turn. So think about that, right? 400 CFM. If you have a 1 ton unit outside, you need 400 CFM. You have a 2 ton unit outside, you need 800. So do you understand? So it goes by that. And then again, you're still looking at your manual. I can't tell you guys how many times this is really important, that you look at your manual for your outdoor unit, you configure this out and see, hey, we're still inside though, because we still got to go back to the furnace. We still got to go back to the furnace. And because we're going to have the wires there on our board for the cooling outside. Because remember, it's that fan. We're still talking about the fan, even though we're talking about outside air condition, the fan still remain the same. So we look and see in our book, okay, how much do we need for cooling? So if we have a 2 ton, we know we have 400. If we have a 2 ton, we know we need 800 CFM, and we only deal with, in the air conditioned field, we deal with what, 1 ton, 2 ton. We do with a little half ton, so you might have 2.5, 3.5, 4 tons. I don't remember working on anything bigger than 4 tons of talking about residential stuff. So if you guys ever work on anything more than 4 ton, tell me about it. I've just never seen it. So you'll still do 400 CFM per ton, and that again is simply design. That's all we're working on, is design, and making sure that it's designed again correctly. What you could do, you could go outside and you could see what unit you have. So if you see you will tell you 2400 BTUs. That's a 2 ton unit. You know what I'm saying? Because remember, it's 1200 BTUs per ton. So you understand what I'm saying? So if you have, you have a 36. So, and then they work the numbers, and you look at your book and make sure that it is done correctly. Another thing, that once you're dealing with outside with your air condition, the biggest factor is your refrigerant level. Now, how do we determine what's our refrigerant level? Well, I mean, if you're not a technician, that one might be, a little bit hard for you. But what we're gonna do is that most times when we doing air conditioned unit, what we do, it normally comes configured with refrigerant for 15 feet. Anything more than 15 feet, we're going to add 0.6. So if you have a 20-foot line, you go just add 0.6 times 5, and that is the amount of refrigerant you need. Your technician definitely is going to tell you if you need refrigerant or not. So these are some of the stuff that I wanted to kind of go through with you guys. In our next video, I will definitely want to go through a little bit more and tell you about how to tell if the unit is working, what the unit is doing. So if you stick with me, we're just going to talk about that design and what we should have, what should be happening. And I said before, there's a lot of things that come into place. So having the correct ductwork. And if you have an older house that was designed, most times you don't want to just go and change and make that mistake, and somebody say, hey, give me a bigger unit. Well, your ductwork wasn't designed for a bigger unit. So most time your house are built, it is designed for the unit that's there. So changing to a bigger unit, you could really create some problems, and changing to a smaller unit, you could create some problems. So you want to make sure that your unit you have, if you're going to do a replacement or if you're going to change that unit, make sure that you're doing it with the same unit that is there, because you didn't design, unless you're going to bring somebody that is very versed and they could come back and measure your stuff, and then they could tell you what's the unit that you need. So very important stuff, guys. So I'm gonna be leaving off in a little bit. Just wanted to kind of touch base with you guys and let you know exactly how this thing work, because this for me here, this is really really important stuff. All right, guys. So thank you guys, and see you on our next video. And don't forget to comment and subscribe, guys. See you.